In the given question, we will have to apply depth first search using stack on the given graph, and then we will have to tell that okay, at any point of that calculation of depth first search, how many maximum number of nodes will be there in the stack. Okay, so we will start with j just because they have given the starting node as j. So at the very first, my first step will be I'll have to push j in my stack. So at first I'll have to push, this is my stack, then j I'll have to push into the stack. After pushing this, I will have to process j, and in the second step I'll have to push all the neighbors of j. So j will be removed, popped from the stack, and it will be processed according to my depth first search, and all the neighbors of j will be pushed onto the stack. Let's say I am pushing them in this sequence d and k. So k is at my stack top. Okay, so after that I will process k, that is my stack top, and after processing k I'll have to push all the neighbors of k which are not in the stack or not yet processed. Okay, not in the stack and not yet processed. Okay, so the two nodes I am having, that is e and g, which are not yet processed and not yet in stack. So I will push those nodes into the stack. In the next step I'll have to process the node which is at the top. Okay, I am assuming that the node which is at last, that is my stack top. Okay, so I will process g, that means from stack g will be removed, and all the neighbors of g will be pushed onto the stack. I am having two neighbors of g, you can look at in your graph, that is c and e. So e is already in my stack, so I will push c onto the stack. After that, in fifth step I'll have to process the node which is at the top, that is my c. I have processed, it will be removed, and I'll have to push the neighbors of c onto the stack. Neighbors of c will be including f only, so I'll push f onto the stack. In the sixth step, stack combination will be d comma e, that just because I'll process f, that is my stack top, and I'll have to push all the neighbors of f. Now all the neighbors of f means it is d, so d is already onto the stack, that means I will not include it in the graph or in the stack. Okay, so that means there is no any push on this step. After that, in the next step I'll have to process that particular node which is my stack top, that is e. After processing e, I can see that my stack will be d only, just because the neighbors of e, that is c, j and d, either already processed or already in my stack. So I will not push any other element or any other node onto the stack, and after that I will process d, that is my stack top, and stack will be empty at the end. So according to this particular depth first search, at any point maximum number of nodes in my stack is at step number 3, 4, 5, and this is equal to 3. So my answer should be 3.